Yeah, it's coming stream finished.
So I will log in once more then.
Just a minute. Yours is finished, man. I don't know what happened to this.
So we have logged in now.
Wait. Something is happening here. It's running now. Yeah. Okay. Yeah, it's running. Let it be. I will see. Can you open Avanti Live 2 in your YouTube? I also wait. Yeah, wait. Hello students, how are you? How are you all? JNV Ahmednagar. Yeah. Okay, so good evening, guys. Good evening, everyone. So I don't know why students haven't joined yet. So we'll see time, and then let me discuss about the things which we are discussing in the previous class. So in the previous class, we discussed about the UPSC naming and all, right? And the today's class, our major focus will be on. Just let me keep my screen well so that I can receive myself. Okay. Right, so everyone is joining now. So we will see the people who are joining it now. And today we are going to discuss about the preparation of alcohols. So the preparation of alcohols is going to be discussed today. And again, once again, guys, take pen and paper out and try to sit in front of your PCs very well. Take pen and paper. And very most important thing is I'm going to discuss about about the CBSE only. So basic focus will be on the CBSE only. You don't worry much. Okay. So what I'm telling to you is like you just focus on the CBSE only. So my dear YouTube friends and all others, just take the pen and paper, try to work on it. Okay. Right. So now we are going to talk about the preparation of alcohols. So basically preparation of alcohols can be done from alkenes. Okay. Especially we'll be focus preparation of alkenes from the alkenes. Okay, so how do you are we are going to prepare? Hello Buldana, how are you guys? Right, so how we are going to prepare? So by using the reagents, how we can go do the what you say, the preparation for the alcohols. So there are basically three reagents today I'm going to talk about. Yesterday I have already given. One is acid catalyzed reaction, or we can say acidic hydrolysis. Simply I can say acidic hydrolysis. Okay, acidic hydrolysis. Okay, or we can also say that acid catalyzed reaction where you are having H plus and HCl, or we can simply say that HX. So H plus we can be, sorry, H2O guys. Okay, so this H plus can be come from any particular acid like HX or HCl, HBr and all. Usually we'll discuss about that one in detail, but generally H plus is indicates the is acid acting as an catalyst, means again at the end of the reaction it will come back again. Now, whatever the other one is OMDM. What is OMDM? Oxymercuration and demercuration. Oxymercuration and demercuration. So how it is going to useful, guys? This is going to useful as HgOAc, mercury acetate, in the presence of tetrahydrofuran, and it is actually two step one, and the second one is you are using a reducing agent, that is NaBH4. Okay, where you will get an hydrate from here. Okay, so this is what you are going to have. right? In H2O is also be there, along with that H2O will be present in the presence of tetrahydrofuran. Next, third one is, we are very most important from our examination point of view, HBO. HBO means what? Hydroboration oxidation. What is this? Hydroboration, hydroboration and oxidation, hydroboration and oxidation, है ना? So this is what we are going to see. And remember, these first two are following Markovnikov rule, and this one will follow anti-Markovnikov rule. And in Markovnikov rule, first one will be focusing on the stability of carbocation. First one will be based on the stability. First one will be based on the stability of carbocation. Okay. And the second one is, okay. So whenever we are talking about stability, one thing you need to remember is rearrangement. What you have to remember? Rearrangement, or we can also say that ring expansion. Rearrangement and ring expansion. Second one is Markovnikov rule. So Markovnikov rule is simply nothing but it is not depending upon the rearrangement. So there is no rearrangement will be takes place. Yes, even though carbocation will be formed, but no rearrangement will be takes place. So this will follow anti-Markovnikov rule. So now, first of all, what is Markovnikov rule? We'll discuss. Many of you know about Markovnikov rule, but still we are going to discuss about the Markovnikov rule. What is Markovnikov rule? Let's suppose if we are having any alkene. So let's suppose if you are having any alkene. So like this, it is there, CH3CH double bond CH2. Okay. So let's suppose if you are having any alkene, right? So let's suppose we are having any alkene and we are using any particular reagent like HX, okay, where you are getting H plus and X minus. Okay, so now according to the Markovnikov rule, what it suggests is that, so the electrophile, or we can say that E plus or H plus electrophile, or we can also say it is a proton in this case, okay, because no electron left. So if you see hydrogen is having 1s1 and H plus is called as proton. What we are going to call it as proton. Why H plus is called as proton? Because no electrons, only protons will be there. No electrons, only protons will be there in H plus. So that is why H plus is called as proton. So it will add to the carbon, which is having more number of hydrogens, okay. So now this H plus can be go to this carbon and this carbon. Let's suppose 1 2 3. So 3 will not at all involve in addition reaction, will takes place at unsaturated carbons. So this is actually taking place at addition reaction. So Markovnikov rule is addition reaction. So the H plus will be added only unsaturated carbons. What are unsaturated? Unsaturated are double bond or triple bond. Now the question here is like, we are having number 1 carbon, number 2 carbon. Where H plus will attack? Yes. So according to the Markovnikov rule, H plus will attack to the carbon where you are having more number of hydrogens. Now at C1 carbon, you are having 2 hydrogens, and at C2 carbon, you are having 1 hydrogen. So the number of hydrogens are 2 in C1 and C2 is 1. So definitely H plus will attack here, but not here. So now H plus will be attack here. So whenever H plus is attacking here, that means what type of charge will be developed at second carbon? Yes, CH3, CH, positive charge, CH2, and this hydrogen is attaching here. So now you form a carbocation. What we got here? We form a carbocation. So now, whenever, remember guys, very most important, whenever there is a formation of carbocation is taking place, whenever there is a formation of carbocation is taking place, whenever there is a formation of carbocation is taking place, what we need to do? We need to check the stability of carbocation. Need to check the stability of carbocation. So now, how do you find the stability of carbocation? Remember, guys, one of the most important, benzylic cation. So what is benzylic cation? You will have a benzene group which is attached to sp3 carbon, and if it is having a positive charge on it, we call it as benzylic cation. What we are going to call it? Benzylic cation. So benzylic carbocation is more stable than any other carbocations. Why? Because of resonance. Because of resonance, benzylic cation will be more stable. And what is the next stability? CH2 double bond CH bond CH2 positive. So this is here. This is sp3 carbon and this is sp2 carbon. So if a sp3 carbon with positive charge attached to sp2 and sp2 carbon, this particular group is called as what? Allylic carbocation. What we are going to call it as allylic carbocation. So this allylic carbocation is simply nothing but the cation will be present on a carbon which is sp3 and it is attached to a unsaturated carbons, or we can also say between the sp2 carbons. So this is allylic carbocation, and allylic carbocation is also more stable than tertiary carbocation. So what is tertiary carbocation? CH3, C, CH3, CH3. So here this is tertiary carbocation, means this carbon has a positive charge attached with 1, 2, 3. It is attached with 3 carbons. So that's why we call it as tertiary carbocation. Now, why is allylic carbocation stable? Because it is having positive charge, sigma, and we are having pi. Okay. What is happening here? It is having a positive charge. Okay, and it is having sigma bond and pi bond. So whenever if you see pi sigma positive, pi sigma lone pair, or pi sigma free radical, pi sigma pi, if you observe, are pi sigma lone pair and a empty orbital. If you see these kind of systems, we call these systems are conjugated systems. What we call them as? Conjugated systems. What we call them as? Conjugated systems. So in this conjugated system, what you are going to observe? We will observe delocalization. What you are observing? You will observe delocalization. And this delocalization is simply nothing but resonance. This delocalization is simply nothing but resonance. So allylic carbocation is more stable because of delocalization. That is, this is the conjugated system. So allylic carbocation is a conjugated system. So that is why it is having more positive charge. I hope you guys are clear. So again, I'm repeating, stability of carbocation. Stability of carbocation will be first benzylic cation. So how to find the benzylic cation? CH2 plus, next one is what? Allylic carbocation. Allylic carbocation means CH2, CH2 positive. Allylic carbocation. And next, tertiary carbocation. How to write the tertiary? CH3 taken thrice carbocation. Next one, secondary carbocation. CH3, CH carbocation. And primary carbocation. CH3, CH2 positive. Okay, so this is the order of carbocation stability. This is the order of carbocation stability. So now everyone need to remember that whenever there is a carbocation is taking place, if you see this reaction, CH3, CH double bond CH2, if I am doing H plus in the presence of H2O, what is the first case it will happen? The first will be H plus will attack the carbon which is having more number of hydrogens. Now the product will be CH3, CH, CH2, and you are having the product. Here H is attached, you are getting a positive charge. Now this positive charge, the carbon is attached with two other carbons. So that is why we call it as a secondary carbocation. It is attached with two other carbons. So that's why we call it as a secondary carbocation. So this is secondary carbocation. So we have to see, can we convert them into tertiary? So we can't convert them. So next, what is going to happen here? In this case, you are having H2O, right? So H2O is having lone pair of electrons. Now these lone pair of electron, which is a nucleophile. which is a nucleophile. So this nucleophile will attack the carbocation. Now what will going to happen here? Now it will be CH3, CH. Here oxygen is attached, OH, and when oxygen is given its lone pair, so that is why oxygen will get positive charge. And here what is there? CH3. Now positive charge on oxygen is unstable. What it will do? It will take the shared pair of electrons from any one of the hydrogen by releasing it as H plus ion. So I told you H plus is acting as a acid catalyzed. So again H plus will go out as a acid catalyst. So now what will going to happen? CH3, CH, CH3 bond OH. I hope you guys are understand this one. Okay, so in simple shortcut, I will give you some of the examples. Then you can write CH3, CH double bond, CH bond CH3. And if I am having acid catalyzed reaction, so here H plus will can add any of the carbon. So here it can add or here it can add. So the product will be CH3, CH bond OH, CH bond H, CH3. Next one, CH3, CH, okay, CH3, CH double bond CH2. So now if I am going to take the H plus, what is the first step? H plus will attack the carbon where you are having more number of hydrogens. Two hydrogens are there. Now what is the carbocation formed? CH3, CH, CH3, CH positive charge and CH3. Now when the hydrogen is attached here, you'll get a carbocation. Now see this carbocation is secondary carbocation. This is what? Secondary carbocation. How, sir? Number one, number two. This carbon is attached with two carbons. So that is why this is a secondary carbocation. Now this secondary carbocation, what we have to see? We have to see, can we rearrange, can make it as a tertiary carbocation? Can we rearrange and we can make it as a tertiary carbocation? Yes, we can do. How we can do? That is shifting. So now 1, 3 hydride shift. 1, 3 hydride shift. Okay. So now we have to shift the hydride here. Okay. Whenever we are shifting the hydride from here to this carbon, now what will going to happen? CH3, C positive charge, CH, H, CH2, that is CH3, and this is CH3. Now you can see this is 1, 2, 3. So this carbon is attached with 3 carbon. So that is why this is tertiary. So try to see, can we convert secondary to tertiary? Now what will going to happen here? Now H2O is there, then H2O will come and attack here on this carbon. So your final product will be CH3, C, OH, CH3, CH2, CH3. Okay. So like this, you are going to get it. So now next example, CH3, C, CH3, CH3, C double CH double bond CH2. And again, if you take H plus H2O, again you will get a positive charge here. And now this time you will shift methyl here. Now the final product will be CH3 bond OH, because what we have shifted here, we have shifted methyl. Methyl shifting is takes place. What is happening here? Methyl shifting. CH3 OH, CH3, CH, CH, CH3 bond CH3. Okay, so now this is what it will going to happen, guys. So I hope everyone understand this one. So this is how the rearrangement will takes place. So this is what the rearrangement. So here CH3 methyl has been shifted to this carbon. Why? Because this is going to form a stable carbocation. This is going to form a stable carbocation. So stable carbocation will be the key, and that is what you are going to answer on matter. Okay, so this is about the Markovnikov rule for the acid catalyzed reaction. Okay, next we are going for what? Next we are going for OMDM. What is OMDM? Write down in your notes. Oxymercuration, oxymercuration, oxymercuration and demercuration. Oxymercuration and demercuration. So how this oxymercuration and demercuration takes place? How this? Very simple. What is the reagent here? I told you already. What is the reagent here? The reagent is Hg mercuric acetate in the presence of tetrahydrofuran, okay, and followed by a reducing agent, that is NaBH4 in the presence of H2O. So this is the reagent. And what is the product you are going to get? Product will be alcohol. Product will be alcohol. But what is the mechanism it will undergo? It will undergo what? Markovnikov rule. It will undergo Markovnikov's rule. Okay, so here rearrangement takes place or no? Very most important. Very most important is no rearrangement takes place in oxymercuration and demercuration. No rearrangement will be takes place. I hope you guys understand this one, right? Okay, so let's say best example CH3, CH, double bond CH2, and if you are using first HgOAc twice H2F, okay, and NaBH4 H2O is there. So this is OMDM process. So then now it will become CH3 CH, okay, CH3 CH CH3 CH bond OH CH3. Simultaneously CH3 CH bond CH double bond CH2, and if you are having CH3 here, I told you again OMDM we are doing. OMDM we are doing oxymercuration and demercuration. So if OMDM we are doing, again H plus will come here and again OH will be, but there is no rearrangement. No rearrangement. No rearrangement. When there is no rearrangement, then it will be CH3 CH CH3 CH bond OH and CH3. If you keenly observe here, this particular carbon is a chiral carbon. This particular carbon is a chiral carbon. Why, sir? You can only see, sir. Here only you can see this is one arrangement. Okay, this is one arrangement. We can also say iso group, and here hydrogen is there, and methyl is there, and OH group is there. So this is A, this is B, C, D. If a carbon is attached with four different groups, if a carbon is attached with four different groups, 1, 2, 3, 4, A, B, C, D. If a carbon is attached with four different groups, then we call it as a chiral carbon. So how many products will take place here? Here the number of products will be 2. What are the D isomer and L isomer? Usually both are enantiomers. So oxymercuration, demercuration, this particular product can give what? Enantiomers. Can give what? Enantiomers. Sir, what are enantiomers? Here the chiral carbon is present. If you draw the mirror image of this one, then you will get it. So if this is D isomer, next one will be L isomer. So two products will be going to optical products you are going to get. Two optical products you are going to get. Okay, so that is what you people need to remember, guys. Yeah. Next one, third one, very most important one, that is HBO. What is HBO? Hydroboration oxidation. So what is the reagent here? What is the reagent here? What is the reagent, guys? So the reagent is pretty simple. That is B2H6 in the presence of tetrahydrofuran. Okay. And along with that, second one will be H2O2, which we can also call it as peroxide, which we are also call it as peroxide. So whenever there is a peroxide will be there, what type of mechanism it will take place? Peroxides will be always used for the anti-Markovnikov's rule. Anti-Markovnikov's rule. Markovnikov's rule. We can also call it as Karash effect. We can also call it as Karash effect. So which is a reverse of Markovnikov rule. So simple H plus will go to more number of hydrogen Okay, in Markovnikov rule. So then what will going to happen in anti-Markovnikov rule? Anti-Markovnikov rule, H plus will go to less number of hydrogen contained carbon, less number of hydrogen contained carbon. Now, best example, if you see CH3, CH, double bond, CH2, and if I am taking, okay, if I am taking this one, H plus in the presence of H2O, so this H plus will have 1, 2, 3. So 3 it will should not go because of addition reaction. The H plus will go on the second carbon because of what? Karash effect or anti-Markovnikov rule. Okay, so because it will attack on the less number of carbons. So now what will be the isomer what will be the carbocation you are getting? CH3CH CH2, that is CH2 positive. Okay, CH2 positive. So this is primary carbocation. This is primary carbocation and no rearrangement takes place. And no rearrangement takes place. No rearrangement takes place. So this is the primary carbocation and the end product will be hydrolysis. At the end product will be CH3, CH2, CH2, OH. Okay, so this is, we can also call it as propanol. This is also we call it as propanol. I hope you all guys understand what is B2H6 reaction. So I am extremely sorry guys. HBO, right? I was doing this one, acid catalyzed reaction. I'm extremely sorry guys. Just a minute. I have done it. I was just simply in flow. Okay, forget about that one. It will be, it is not, it is wrong. That is CH3, CH double bond, CH2. The reagent is this one, that is B2H6, the presence of tetrahydrofuran. First one, what will going to happen here is like the B2H6, it will exist in the form of like this HBH2. Okay, HBH2 twice, HBH2 twice. कोई problem नहीं, just be right like that. So again, this is simply nothing but what? B2H6 only. So now it, what will going to happen? This H plus will attack on the carbon which is having less number of hydrogens. So this H plus will be attacked on less number of hydrogens. Now CH3, CH bond H, okay, and then next bond CH2. Next, here BH2 will attach. Here BH2 will going to attack. I hope you guys understand this one. Okay. So next, further under the peroxide, what will going to happen? Under the peroxide, you are going to release OH minus. So from here, what is the product, guys? CH3, CH, CH2. This is CH2, OH. Usually remember in HBO method, primary alcohol will be more stable than secondary than tertiary. Usually tertiary is not followed, but primary and secondary are the favorable products for the HBO because of what? Because of they are having peroxides. Okay, we can also call it as Karash effect. Okay, guys, just let me give you some examples so that we can move. Okay, finally, I will write here RCH double bond CH2. Okay, right. So I'm going to write the reagents here. So that is first one is what? H plus in the presence of H2O. This is acid catalyzed reaction. Acid catalyzed reaction. Next one is OMDM, oxymercuration demercuration. That is Hg, OAC twice, THF, that is H2O in the presence of NaBH4. Okay, and next one is what? HBO. Okay, hydroboration oxidation. The reagent is B2H6 in the presence of H2O2 and the tetrahydrofuran. So what is the product here? So the products are very simple. Here rearrangement will take place. Rearrangement will take place. What is the product here? That is RCH bond OH CH2. Okay, here these both will undergo Markovnikov's rule. This both will undergo Markovnikov's rule. And what about this one? This will undergo anti Markovnikov rule, anti-Markovnikov rule. So the product will be RCH bond OH, CH2, and this is H, CH2, H. Next one, RCH bond OH and CH2, H. Okay. So sorry. This is wrong. Last product will I have written wrong. So now here it will be hydrogen and here it will be OH. So usually primary alcohols will be favor for HBO and tertiary secondary will favor for the OMDM. So both will write secondary and tertiary carbocation. Here this is primary carbocation will be favored more. I hope you guys understand this one. If you are clear with this, please let me know through the chat box. If you are clear with this, please let me know through the chat box, guys. Without going the mechanism, just remember this one, how to do for the exams. For the sake of exams only, we need to remember. Clear, guys? Tell me in the chat box if you are clear. Yes, very good. Right. Next one is reduction. Next one is what? Reduction. So how do you do the reduction here? Reduction from which type of reagents? I'm going to write the reagents first here. So I'm going to write the reagents. Voice not clear? Guys, am my voice is not clear? Please let me know through the chat box. Guys, am I audible? Please let me know through the chat box. Is my voice is audible, guys? YouTube friends, please let me know through the chat box. Others, Rajkot, Basmat Nagar, please let me know whether my voice is audible or not. Clear, right? Very good, very good. So now I'm going to write the reagents. What are the reagents? LiAlH4. So Basmati, I don't know which institute. Basant Nagar, right? Which institute this one? Basmat Nagar. Basmat Nagar people, please turn your Wi-Fi off and on. There might be network issue from your side. From my side, network is very clear. LiAlH4, NaBH4. Okay, and the next one will be H2 in the presence of palladium or platinum. Okay, this is very most important reagents. So very important is these two will always give a hydride ion. What they will give? They will give hydride ion. Okay, and here also this is going to helpful in the reduction of alkenes to alkanes. So very most important. I am going to write the reagents. Let's suppose LiAlH4. Okay, and I will write here. Just let me arrange. Okay, reagent. First one is reagent. Okay, then which is giving positive test and negative test. So first one I'm going to write here is like aldehydes. Next one ketones. Okay, acids and alkenes. Okay, among these three reagents, which will give which test? Reagent of NaBH4 and LiAlH4. Next one is H2 in the presence of palladium or platinum. H2 in the presence of palladium or platinum. NaBH4 can give positive test for aldehydes and ketones, but not acids and but not alcohols. Okay, but whereas then LiAlH4 can give aldehydes, ketones, and acids, but not alkenes. So I will change the color here to remember this one. Okay, so LiAlH4 can reduce aldehydes, ketones, and acids. Okay, but NaBH4, this is called as sodium borohydrates. This is called as what? Sodium borohydrate. Sodium borohydrate. What about this one? Lithium aluminum hydride. Lithium aluminum hydride. Lithium aluminum hydride. And this one is simple hydrogen in the presence of platinum and palladium. This will give all positive test. This will give what? All positive test. It can reduce, or we can say that it can help in the reduction of all type of things. So very most important, guys. Just remember this trick and we will do in the further process. Okay. So now let me check you some of the examples. I'm going to write here. Okay. Reduction. Let's suppose if I'm writing for aldehyde CH3, C double bond O, H. If I'm first, I have to do what? I have to use any reagent like LaLH4 or I have to use NaBH4. Okay. So second, what I have to do? I am using H2O in the presence of H plus C means next I am doing acidic hydrolysis. So from here, I told you from these two reagents, what you are going to get? You are going to get one hydride ion. Okay, you are going to get one hydride ion. So here you are getting hydride ion. So now this hydride ion will attack the carbon because it is getting partial positive charge and this will get partial negative charge. Now what will going to happen? CH3, CO partial negative and this one will become partial positive and here H. Now hydride will attack here and it will make what? CH3, C, H, H and O like this. And now H2O in the presence of H plus. Now H plus will attack on oxygen. So now the final product will be CH3, C, OH, H, H. So always remember aldehydes, aldehydes upon reduction will give what? Primary alcohols. Will give what? Primary alcohols. And next one, ketones. Ketones what? Ketone upon reduction will give what? Secondary alcohols. Ketones upon reduction will give secondary alcohols. Very most important. Very most important, guys. Okay. I hope you all are clear with this. I hope you all are clear with this. Yes, they can also reduce. I forgot to tell, they can also reduce ethers. Ethers also can be reduced, but we can also use a diol H. We can also use a diol H, that is diisobutyl aluminum hydride. We'll study about this one. Okay. So just this is what you people need to remember. And the next one. Okay, so next one, let's suppose I'm giving some of the examples. CH3, CH2, C double bond O, H, any reducing agent like NaBH4 or LiAlH4, ये हो जाता है first reagent where you will get H minus from here and second reagent. What is second reagent? Second reagent is H plus in the presence of H2O, or we can also take any acid HCl. Okay, you can also take any acid HCl. Okay, sometimes to confuse you in your examination, they will give D plus D2O. In your examination, they will give D plus D2O. What is D here? D here is a deuterium ion. What is here? D is a deuterium ion. D is deuterium ion. Okay, so now what will going to happen here? This is aldehyde. This is what? Aldehyde. So now this aldehyde will try to help in the formation of alcohol. So what type of alcohol you are getting aldehyde for that? Primary alcohol. So now the product will be CH3, CH2OH. Just to remember. Oh, another carbon is there, right? So that is why you have to remember CH3, CH2, CH3. Okay. Next one, if I'm going to take CH3, C double bond O, CH2, CH3. Ketone is there. Again, if we are using any reducing agent, the product will be CH3, C bond OH, CH bond CH2, CH3. So here this is secondary alcohol. This is what? Secondary alcohol. Okay. So very most important. Now CH3, CH double bond, CH bond, C double bond OH. So here LiAlH4, NaBH4 will not going to work. Okay, only work which is going to work? H2 in the presence of palladium. Okay, so that means your matlab, these can also reduce, but they can't reduce what? Alkene. So I'll take in another slide. Let's suppose CH3, CH double bond CH bond, C double bond, go H. Now if I can take like this, first one is NaBH4, okay, and second one is LiAlH4, okay, and third one is what? H2 in the presence of platinum and palladium. So listen to the products, guys. These cannot be reduced. So both 1 and 2 cannot reduce what? Cannot reduce alkenes, cannot reduce alkenes. So now the product will be CH3, CH double bond, CH bond, CH2, OH. Here same CH3, CH double bond, CH bond, CH2, OH. Next one H2 क्या है? It can reduce alkenes. It can reduce alkenes. So now it will become CH3, CH, H, CH, H. Next I am writing here final product. I am writing here that is CH3, CH, H, CH, H, that is CH2, OH. So it can reduce both alkenes and the aldehydes. I hope everyone understand this one. Okay. So the time is already up. Okay. I don't want to waste much time of yours. So just think of it, how to do these things and all. Okay. And another important thing is like preparation of ester is also takes there. One example I will give and then I can close. So let's suppose if I'm having CH3 C double bond O OH plus, or if I am taking methyl alcohol HOCH3, this is methyl alcohol. Now both will go as what? Now both will go as ether. So both will go. How they will go? How they will go? They will go in the form of H2O. Now CH3 C double bond OH3, which is nothing but ester, So how the ester will look? RC double bond OR, or in some books it will represent as RCOR. So you are getting ester here. So now further, if you are taking palladium or platinum or any strong reducing agent, what they will do? They will reduce them. They will reduce. So they will reduce the ether groups. They can reduce this also. Now the final product will be CH3. Okay. So that is CH2. They are reducing all the ester group. Then they are making simply an alcohol. So these are strong reducing agent. These are strong reducing agent. Okay, guys. That's it. Thanks for watching patiently. Okay. So very most important, esters can also be reduced. Esters can also be reduced to alcohols by using a strong reducing agent. Okay. Thank you so much, guys, for joining the class. See you in Monday, because very most important thing is like you people have done patiently. Thank you so much. Thank you. And another most important is like happy Christmas to you all. Happy Christmas, guys. Okay. May this Christmas will bring you most glory and happiness in your family, and all the best for your exam. All the best for your tomorrow's FSC test. All the best for your tomorrow FSC test. Okay. See you guys. Always keep smiling. Okay. Merry Christmas, guys. Always keep smiling. Bye.